particular solution. Okay? So all that particular solution means is we want the slope field at one specific moment in time. They're going to give us like an initial condition. So we're going to do the exact same thing we did when finding the general solution. So I'm going to rewrite this function down. dy dx equals xy squared. Okay, so I still want to separate the variables. Get the x's on one side, y's on the other. Obviously, I'm squaring both of these, so again, I'm going to rewrite that as x squared and y squared, so I can separate them. Multiply that dx over. Some people, I don't know, some people are having trouble separating the variables, which caught me off guard. I guess if that's you, you could put this over 1 and cross multiply if that's easier, but I'm just multiplying both sides by dx to eliminate that fraction. So I have dy equals x squared y squared dx. And then I obviously want to move over the y squared. So first of all, we said if we can't separate, it's an automatic 0 out of 6, and it's a 9-point question. You have to make sure you separate. Take the time, make sure you separated correctly. Okay, this is what will lead us to our first point. And our goal is to get, 6 would be great, 5 would be great also. You don't have to get a perfect 9 on all these free response questions to get a 5 on this exam. There is a huge gap on what a 5 is. It's a range of scores. So we typically say if we can get a 7 or above, like you're in amazing shape. You do not have to ace every single question. Okay. So now again, we separated. We're going to integrate. The left side, obviously I have to rewrite. I can't have a variable in the bottom, so I'm going to rewrite that as y to the negative 2 dy equals the integral of x squared. Okay, and then just integrate. So I get y to the negative 1 over negative 1. X cubed over 3 plus c. So just again, just the power rule for integrating. And rewrite that as negative 1 over y equals x cubed over 3 plus c. Now that's where we left off 2 days ago when we said we're solving for these general solutions and then we would get y by itself. So we're going to go one extra step here. We want a particular solution. So yes, we see this slope field. We can kind of see what it's doing, but we want it at this one moment in time. So we now have to solve for c. So when they give you this condition, you are solving for c. You're going to plug 1 into x and 1 into y in this case. I'm going to have negative 1 over 1 equals 1 cubed over 3 plus c. So that gets me negative 1 equals 1/3 plus c. I'm going to subtract that 1/3 over. So I've got c equals negative 4/3. Now, I'm not done until I solve for y, remember. Okay, I just got the c value, and I have to go solve for y. So I'm going to go back to my equation, and I have to plug this c in there. So I have negative 1 over y equals x cubed over 3 minus 4/3. I'm just going to throw that as one fraction. They already have common denominators. So I have negative 1 over y equals x cubed minus 4 over 3. Okay, I want to get rid of the negative because I want y by itself, so I'm just going to divide that negative over. I am running out of room here. I'm going to put my work over here. So I'm going to say I've got 1 over y equals negative x cubed plus 4 over 3. Again, when I divide it over, I'm not going to divide every term. I'm either just going to do the top or the bottom, right? If I divide everyone, then I didn't change any signs. Okay, and then I can use that quick tool about reciprocals of both sides. If I want y by itself, I can just take this reciprocal, so I just get y. And I can take this reciprocal, so I get 3 over negative x cubed plus 4. Okay. So we call this the particular solution. So we have a general solution. We have a general idea of what this function looks like. So now we have the exact solution to this graph. And then we're going to go ahead and plot that. So we wanted 1, 1 is our point. So we said we're going to make our point bold. Okay. It's like dropping that leaf in and kind of going with the current. Try to draw what you see through that 1, 1. This one particular differential equation through that point. looks like it flows up like this. And we said go to the end of the graph, no arrows. I do notice that right on the x-axis, it looks like there's a what? A horizontal asymptote. So again, you're just getting closer and closer. But there's definitely an asymptotic feature there. Okay. So as far as differential equations goes, this is kind of like the end of, we're kind of like at the end of it. We're gonna do a little more with slope fields, next week, but this is pretty much the whole chapter. We have to be able, the big part is finding these particular solutions. And obviously the integration techniques are gonna be different on everyone, whether it's a U-sub or whatever it is that you see. But we'll practice a few more together here. These are very simple ones, obviously. These equations are not super complex. Let's go ahead and try, whoops, I just broke my pencil. Try number 2. So take your functions, separate your variables. Integrate both sides and then try to solve for that plus c. In my head. How's that sounding for C? Let's see, if I write it out, I get y squared over 2 equals 2x squared over 2 plus c, bless you. Plug in my 2 and my 1, so obviously x and y. So that gets me a 1/2 equals 4 plus c. And if I subtract my 4, that's 1/2 minus 4, which I'm really going to call 8/2. I get a negative 7/2 for c. Okay, so your c value isn't always going to be a beautiful number. Sometimes it's an ln, sometimes it's an e, fractions, whatever. C can be anything. So now I'm going to go back and substitute that in. So I have y squared over 2 equals x squared minus 7/2. Okay, so now it's kind of all about your algebra cleanup. I want to get to y. I want y by itself. So obviously I want to get rid of this 2. So I'm just going to multiply everybody by 2. That would clean up that 2. So I'm going to get y squared equals 2x squared. And then this times this 2 makes it just minus 7. To get that y by itself, I want to take the square root. I just can't forget to put a plus and minus. That is huge. 2x squared minus 7. Okay, and now with a particular solution, you have to determine if you want the positive answer or the negative answer. And let me just explain why visually. We don't do a ton of these graphs that you're probably like recognizing what this looks like. But this function itself, if it passes through the point 2,1, and you don't need to draw it in yet, but if it passes through the point 2,1 and it's plus and minus, that means it looks like this. And if it looks like this, it's not a what? It's not a function, so we can't use both plus and minus. So we have to determine which one we want. Now, if you had a slope field, it's going to be super obvious because it's sitting above the x-axis. But when you don't have the slope field, all you want to do is you want to write down that point 2,1, and you want to say, when I plug in 2, I need to get a positive 1. So if I plug in 2, 2 squared is 4 times 2 is 8 minus 7. If I take the square root, do I want the positive square root or negative square root to get me a 1? Positive, right? Because we got 1 here, so I want a 1. So I want the positive square root of 2x squared minus 7. Okay, you want to make sure your condition checks out. Just by plugging it in, you'll know which one that you want. Okay, so now when I graph that point 2, when I am going to graph it here, kill all this, be super careful about some of those rules for graphing. You have to make sure you have a function. If you have an undefined slope, you have to stop. So it makes sense that this continues this way, but you'll notice all along the x-axis, we have these vertical tangent lines, which are undefined. Must be a little aggressive this morning. I keep breaking this pencil. When I get to this point here, I'm going to circle it with an open circle saying it does not exist, and I just want that top half. Okay, so again, make sure your equation is always a function when you sketch it. All right, so the big kind of takeaway is don't forget that plus minus on those square roots, and then you'll have to determine which one you want at the very end based off your initial condition. All right, 3 again, probably the most important, trickiest one on there. So I'll give you a minute, not the integral part, but just a part at the end there. Take a minute, separate your variables, integrate both sides. Trying to get that plus C part. Figure out what you're getting for a C. So remember, when we have these, we got to get that C value. After you separate, go get that C value. I am getting -1 for C. I can talk through my work if we need it here. So I dy over y plus 2 equals e to the x dx. E to the x was a simple integral. The derivative of e to the x is e to the x, so I get e to the x plus c. Definitely need a u sub. I don't know this integral off the top of my head. There's a fraction. U is y plus 2, so du equals dy. So I had du over u, which becomes the integral, or becomes ln of y plus 2. Okay, right when I integrate, I need to go get that c value. So I'm plugging in a 0 and a -1. I end up with the ln of 1, which is important that you know your graph because the ln of 1 is 0, so that wipes that out. And then I just move that over to get c equals -1. Anybody stuck? I can talk more out. Okay. So now we're going to solve. So try to stay with me on this one because this has one extra step in it that we haven't really discussed yet. I'm going to put in my c value. So I have the ln of y plus 2 equals e to the x plus 1. This one's obviously going to look a little goofy. The only way to get rid of an ln is to take the e both sides, right? And what I mean by look a little goofy is obviously I'm going to get like an e to an e. So that's going to cancel. So I get the absolute value of y plus 2. Don't lose that absolute value. Equals e to the x minus 1. Okay, and I'm going to highlight this because this is by far the most important thing in this one. So I honestly can't remember. I know we don't do this in Algebra 2. I don't know, I don't even remember if it's in your 9th grade curriculum anymore, solving absolute values. It's probably in the middle school at some place. I just want to make a note here off to the side, and again, it's been a while. If I set the absolute value of x plus 2 equals 5, there's 2 ways you have to solve this. You first say the absolute, well, you say x plus 2 equals 5, and then you say x plus 2 equals negative 5. Okay, so make a little note here as a reminder. If you're going to solve an absolute value equation, you set it equal to 5 and you set it equal to negative 5, and then you solve for x. So I would get x equals, subtract that over 3, and x equals negative 7. And now let's see if they check. 3 plus 2 is 5, the absolute value of 5 is 5. Negative 7 plus 2 is negative 5, its absolute value turns into positive 5, and you get 2 answers, right? So here's the catch. When you integrate and you have this ln in here, the only way to get rid of this absolute value is to say you get plus and minus over here. So this has to turn into y plus 2 equals plus and minus e to the x minus 1. Okay, the only way to get rid of that absolute value is to put a plus and minus, because that's how you solve an absolute value equation. And again, by far the most important part is that plus and minus. Then lastly, I'm just going to move that 2 over. So I have plus and minus e. Do I have too many e's in there? I feel like I do. I feel like I have an extra e in there. Sorry. E to the x minus 1 minus 2. Okay. Then your last step is to decide, you can't have both, right? Because the both won't be a function. Do I want the positive version or do I want the negative version? And all you're going to do is say, when I plug in 0, I have to get out a negative 1. So I just kind of put a little note there to check myself. When I plug in 0, I need a negative 1. So let's see what happens when I plug in 0. E to the 0 is 1. Is this a whole thing, the exponent? I've lost what I've written here. I subtracted this over. This is all in the exponent, right? I think so. E to the 0 is 1. Minus 1 is 0. And then e to the 0 is 1. 1 minus 2 is a negative 1. So I would want this to remain positive. So I'm going to say my final answer is e to the x minus 1 minus 2. Okay. So there's 2 cases we're going to have a plus or minus. It's if you're taking a square root, and if you have the absolute value, if you integrate and get an ln, you're going to have to catch that plus and minus. So 2 cases we have to be super cautious of that plus minus. Okay. All right, flip it over. Go ahead and try 1 and 2 there. I don't have answers. I'll get my answers up in a second. Try the top couple there. Again, these are very, very basic. They won't be this simple, but we're going to build up to that. You got the idea. A few minutes to talk it out. Slide next to your partner and talk it out. I think I get the ln of 4 for my c value. You know you're on the right page there, but slide next to my neighbor there. Get my final answer up here. came from. Oh, yep, way more stuff there. Jeez Louise. Okay, so I'm just gonna talk. If you're stuck, pay attention. If you're good, you can ignore me. I got the ln of 4. Okay, so I'm plugging that back in. Again, the only way to get rid of an e is to exponentiate both sides. So I have e to the ln of the absolute value of y equals e to the sine of x plus the ln of 4. It kills that. Now be careful. We have the absolute value of y. So the only way to get rid of that absolute value is to make sure that you get a plus and minus e to the sine x plus the ln of 4. Okay, keep reminding yourself, if you have an ln in your integral, you've got to have a plus and minus when you get rid of that absolute value. Now, this second move to get this answer here, we talked about yesterday. Sometimes you have to decompose that exponent. If I see addition in the exponent, that means this came from multiplication. So that's e to the sine of x times e to the ln of 4. Right? If I added the exponents, that meant I multiplied the bases. And then this is going to cancel out to just a 4. So I have plus minus 4e to the sine of x. And then I just want to say, when I plug in a 0, I have to get out a positive 4. So if I plug in a 0, the sine of 0 is 0, e to the 0 is 1 times 4. For this to be positive, I only want the positive version, 4e to the sine of x. But I always want to check and make sure that I get the number I want with that plus minus. Okay? I think, I'll have to double check, I can't remember exactly. I think if you miss the plus minus, it costs you 2 out of the 6 points. So be very careful. Anytime you have an ln, you got to have that plus minus to get rid of that absolute value. There. I'm going to put answer 3 up here as well. Oops. You got 2, jump to 3? Yeah. I guess the value of 2, but then when I multiplied by 2, that became a 4. You wrote it there. Jeez. All right, so our goal for our weekend homework is going to be through 11. Okay, so not this last page. I don't plan on doing that. You could actually rip that off and throw that out if you want. But up through 11. And my answers, again, I'll just get them posted on Classroom, a fourth period. I'll make sure I get them up there so you have something to compare to. But I'll get my solutions up there. So 1 through 11, and then we'll be in the book next week. We'll probably go test the following week after that, after the 2-day week. Enjoy your weekend.